So I've also drawn segment CG so that I can divide the figure further into triangles and sectors. Okay, so next up is to label some of the known measurements so far in the figure. So first are the angles. So again, this one, angle F is 90 degrees as well as angle D. Okay. CF and CD are radius of circle C. So this one is 3 inches. So let's label that one 3 inches. And so far we have solved for DG, which is 3.67 inches. Okay. So notice that the two right triangles, CFG and CDG, have the same hypotenuse, that is CG. They share the same hypotenuse, I mean, and as well as they have equal sides in the form of CF and CD. Okay, so according to one of the congruence theorems, if two right triangles have the same hypotenuse and length of one side, then the two triangles are congruent. So we can safely assume that CFG is actually congruent to CDG, and that means CG is actually a line of symmetry between the two figures. Okay, so which means to say that whatever area we get from CFG or any portion of it will just be the same as that of CDG. Okay, so we can take the area of CFG first and then multiply it the two to get the whole thing together with CDG. Okay, so let's examine CFG first. So notice that our area or the target area is somewhere here. Okay, again, you multiply the two to get the whole thing. So let's have that one later on. And then notice that we can get that shaded portion by subtracting the area of the sector here, this portion here, with the bigger triangle CFG. Okay, so this one is area 1, area 2. Okay, let's label that one as area 2, and the area of triangle CFG is area 1. So let's label that one area 1 equals area of triangle CFG. Okay, area of triangle CFG. Okay, so again, we have proven that CFG and CDG are actually congruent. So that means FG here is also 3.67 inches. Okay, so next is to solve for area 1 and area 2. But first, let's formulate the area formula for the shaded region. So area, therefore, is area 1 minus area 2, which pertains to this half, first half. So to get the other half, you need to multiply the whole thing by 2. Okay, 2 area 1 minus area 2. Okay, so area 1, I repeat, is the area of the triangle CFG, and area 2 is the area of the sector. So we need to get area 1 and area 2 first before we can go back to our original area formula for the shaded region. Okay, so first let's have area 1, okay, or the area of triangle DFG. So 3.67 and 3 inches are the base and the height of the triangle CFG respectively. So we can use 1/2 base times height. So this is 1/2 times 3 times 3.67. Okay, which will give us, okay, 5.51. Okay, 5.51 square inches. Okay, next is we need to get area 2. Okay, so for area 2, you need 1/2 r squared theta. So we already have the r, 3 inches, but we need the theta first. Here is our theta. Okay, so we will solve for the theta. We can solve it using the right triangle CFG. So again, let's label this one with respect to the angle. So 3.67 is actually the opposite and 3 inches is the adjacent. Okay, so tangent, okay, tangent of theta is equivalent to 3.67 over 3, or theta is arctan of 3.67 over 3, which will give us approximately equivalent to 3.67 divided by 3, so that's around 50.74 degrees. So we need to convert this one into radian to be able to use it on the area formula. So that is times pi over 180, or this is equivalent to so this is equivalent to 0.89. Okay, so area 2 is equivalent therefore to 1/2 times 3 squared times 0.89, okay, which will give us 0.5 times 3 squared. Okay, so this is 3.98 square inches. Okay, the final formula, you have A equals 2 times area 1, which is 5.51, minus area 2, which is 3.98. So area therefore is equivalent to this one is 3.06. Okay, 3.06 square inches. Okay. Something like that.